Good day wherever you are. Allow me to take you through Kcse practical paper 3, chemistry paper 3, the year 2014. You are provided with solution J containing copper 2 ions, solution K 0.1 molar sodium thiosulfate, aqueous potassium iodide, solution L, solution N, sodium hydroxide, starch indicator, and which is called solution M. You are required to determine the concentration of copper 2 ion solution J, the enthalpy change of reaction between copper 2 ions and hydroxide ions. Procedure: using a pipette and a pipette feeder, place 25 centimeters cube of solution J in a 250 ml volumetric flask. Add distilled water to make up to the mark. Label this label this as solution J. Retain solution J for use in procedure 2. B. Place solution K in a pipette. Using a clean pipette and the pipette filler, place 25 centimeters cube of solution J2 in a 250 conical flask. Add 10 centimeters of potassium iodide, solution L. Shake well, then add 2 centimeters cube of starch indicator, solution M. Titrate until a blue-black color appears, and continue titrating until the blue-black color just disappears. So, what I'm saying is that this procedure is very important. You need to understand which solution is reacting with which one. Our table contains these values: 19.2, 19.1, 19.0. Let us take our initial to be 0.0 to 1 decimal place. 19.2, 19.1, 19.0. Calculate the average volume. The average volume, we can see we just add everything, so that is 19.2 plus 19.1 plus 19.0 divided by 3. This one will give you 19.1 centimeters cube. Calculate the number of moles of sodium thiosulfate used. Calculate the number of sodium thiosulfate used. Remember, we are given the molarity of sodium thiosulfate. We have it here that 0.1 capital M. This is the molar sodium thiosulfate, meaning that 0.1 is the number of moles in 1,000 centimeters cube. That's what it means. So we say here that 0.1 is the number of moles which are in 1,000 centimeters cube. But we have used sodium thiosulfate solution K 19.1, so we will ask 19.1 centimeters cube will contain how many moles? What is 19? That's why you need to understand 19 is our volume, this volume here. Solution K is sodium thiosulfate. The average volume is 19.1. We want to calculate the number of moles in 19.1 sodium thiosulfate. So 19.1 times 0.1 divided by 1,000. This one will give you 0.0 0.0191 moles. calculate the concentration in moles per liter of copper 2 ions in solution J, given that the number of moles copper 2 ions in 25 centimeters cube of solution J are the same as the moles of sodium thiosulfate used. The number of moles are the same. Here I want you first to understand sodium thiosulfate reacted with J2 and not J1. What is J2? We took 25 centimeters cube of J and then we diluted it into 250 centimeters cube solution J2. We took 25 centimeters cube of solution J2, we reacted it with solution K, which is sodium thiosulfate. And we have been told that the number of moles of sodium thiosulfate reacted, which is in 19, is the same as in 25 solution J2. That's now fine. So we know that, so therefore moles of 25 centimeters cube solution J2 will be equal to 0.00191 moles. Why? Because the number of moles of J2 is the same as the number of moles of sodium thiosulfate used. We used 19.1 sodium thiosulfate, whose number of moles are this. Therefore, the number of moles is this. But remember, solution J2 was prepared and the volume was 250. So we have now moles in 25 solution J. We can get the number of moles of solution J2 in 250. So we say 25 centimeters cube of solution J2 equal to 0.00191. Then we will ask 250 centimeters cube of solution J2 will be equal to what moles? We multiply this times it divided by this. So that is 250 times 0.00191 divided by 25. This one will give us 0.0191 moles. Now we have the number of moles in 250 solution J2. But remember, we want the number of moles, concentration in J. Right? What is the relationship between J2 and J? Remember, we took 25 centimeters cube J, diluted this J to form J2, which is equal to 250 centimeters cube. Right? Therefore, it means the number of moles in 250, the number of moles in 250 solution J2 is equal to the number of moles in 25 centimeters cube solution J. Why? Number of moles does not change. Moles does not change. What changes is the concentration when you dilute a solution. Therefore, so this means that this is the number of moles in 250. Solution J2 will be equal to the number of moles in 25 centimeters cube solution J. 25 centimeters cube J as 0.0191 moles. Because we wanted concentration in moles per liter, we will ask 1,000, which is a liter. Centimeters cube solution J will contain which moles? 1,000 times 0.0191 divided by 25, which will give us 0.764 capital M. Capital M stands for molarity. Procedure 2. Using a clean burette, place 5 centimeters of solution N into each of the 6 test tubes. Using 100 ml measuring cylinder, place 20 centimeters of solution J in a 100 plastic beaker. Measure the temperature of solution J and record in the table below. To solution J in the beaker, add sodium hydroxide, solution N from one of the test tube. Start the solution the mixture with the thermometer and record in table 2 the maximum temperature reached. Continue with step D immediately. Add the sodium hydroxide solution N from another test tube to the mixture obtained in C above. Stir and record the maximum temperature reached. Continue adding the sodium hydroxide solution N from each of the other 4 test tubes, stirring the mixture and record the maximum temperature each time, and complete the table here below. So in a practical actually is to just follow the instructions. In understanding simple increase, that's okay, will help you to go. So let us see the values which we are supposed to use. When the volume was 0, the temperature, that is the room temperature, then was 22.5. After adding 1 test tube of, that is 5 centimeters of sodium hydroxide solution N, the temperature rose to 24.5. The temperature increased 26.5, 27.0, 27.0, 26.5, and then 26.0. So let us use this data to draw to plot our graph. We want to plot the graph, and then we shall see how to use the graph to answer the questions that are going to follow. Sorry. So I will draw my y-axis, and then my x-axis, I have been asked you to draw or to plot a graph of temperature vertical axis against the volume of sodium hydroxide. So against is the x-axis. So here you write volume of sodium hydroxide used. The volume is in centimeters cube. Here you write temperature because this is the temperature against. So here we write temperature in degrees Celsius. So by doing that, you have scored a labeling mark. And then let us now go to the scale. We know temperature does not begin at 0, but this one, our volume is going to begin at 0, and then 5, 10, 15, 20, 25, 30. Temperature, we will break this graph. We'll break it, and we shall start around 22. 22, and then 23, 24, 25, 26, 27, 28. Now let us use our values to plot this graph. When the volume is 0, the volume is 0 here. So you need to check. When the volume is 0, temperature is 22.5. So 22. So here we have 0.5 at the middle. When the volume is 5, the temperature is 24.5. This is 24 and the 0.5 is here. When temperature is 10, when volume is 10, when the volume is 10, temperature is 26.5. When volume is 10, temperature is 26.5 here. When volume is 15, temperature is 27. 27 is here. When volume is 20, temperature is 27. When volume is 25, temperature is 26.5. 26.5 here. When volume is 30, temperature is 26. So having drawn like that, and you have seen that this is it is a graph that pertains to the topic of energy changes. Therefore, you understand the kind of line you are going to draw here. You draw a straight line you can see this is an exothermic reaction. Its temperature was increasing and then decreased. Therefore, that one you should know. So let us draw this line here. Now look at this one. We have 3.1, 2, 3. We have 1, 2, 3, 4 points. So we take they call them a line of best fit. So we take the line. If I take this one, this point, and this point, I will draw only with 2 points. But if I take this and this and this, I will draw with 3 lines, and that is now the best line of fit. So that's the best. So we are going to draw with this one. Yes. So once we have reached where we have the constant, we extend the line using dotted line. Extrapolate the line. We extrapolate the line. We extrapolate this line also until it meets that one. Very good. Now, where the two extrapolated lines meet, that is the maximum temperature reached, and we can get the volume of sodium hydroxide N used. So since we need the maximum temperature, we go to the temperature axis. We use this dotted, so it means our maximum is, this is 27.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 27.7. That's our maximum temperature. Using your graph, determine the volume of sodium hydroxide solution N that reacted completely with the 20 centimeters cube of solution J. So this is where we have the maximum temperature. So we go down to where we have the volume. So from maximum temperature, we go to volume. So to show that you used the graph, you must draw a dotted line from the maximum point where the two extrapolated lines met. You draw a dotted line down to where we have the volume, and then you see where this, at this point, this is what the volume, this is, remember, this is the volume. Therefore this is 10, this is 15. Therefore two small square represent 1. So this is 11, 12, 13, 14, and then 15. Therefore 13 is here. So the volume is 13 centimeters cube. We use this. So you have to show by using the dotted line. That's why they say from the graph. If you don't draw this dotted line, you won't score that mark. So the volume of sodium hydroxide used is 13.0 centimeters cube from the graph. You have determined temperature change. So temperature, we must have maximum minus minimum. Our maximum was 27.7 and our minimum was 22.5. So you do that mathematically, you find it is 5.2 degrees Celsius. 5.2 degrees Celsius. That is our temperature change. Calculate the enthalpy change for the reaction per mole of copper 2 ions. Mark that, of copper what? Copper 2 ions. So we remember a mixture. We used a volume of copper ions and a volume of sodium hydroxide. But here they have specified that we want to calculate the enthalpy change for the reaction per mole of copper 2 ions. Very important to note. We know that heat change is equal to capital M, mass of the solution. It is capital M is the mass of the solution times specific heat capacity times temperature change. This one is the total volume. The total volume was 20 plus 13. This is the copper ions and this is the hydroxide. So we have 33 centimeters cube divided by 1,000. Remember, centimeters cube is the same as grams. Using this, we know we have done so many. So with density is equal to mass over volume. So if I have volume I have density, I can get mass, so it is 33 grams times specific 4.2 times temperature change 5.2. Sorry. So you take your calculator and multiply all this, you will get 0.07072 kilojoules. Correct? So, but one thing we need to know is the number of moles of copper 2 ions. The volume that we used for copper 2 ions is 20. We should 20 centimeters cube of copper 2 ions were used. Therefore, but we know the concentration of copper 2 ions from our previous calculation. We know the concentration of copper 2 ion solution J from the previous calculation. We know the concentration of J, which is 0.764. This is the number of moles in 1 liter. So we are going to ask, if this is the number of moles in 1,000 centimeters cube, what will be the number of moles of 20 centimeters cube of the copper ions? So 0.764 moles are in 1,000 centimeters cube of copper 2 ions. We will ask 20 centimeters cube of copper 2 ions will give us which moles? This times divided by this, which will give us 0.01528 moles. So this is the number of moles of copper 2 ions that was able to produce this. So now we want 1 mole per mole. Enthalpy change. Remember, enthalpy change, it is per mole, per 1 mole. So we will say 0.01528 moles was able to produce this amount of heat, 0.07072 kilojoules. And then 1 mole will produce what amount? So it is 1 times this divided by 0.01528, which will give you 47.12 kilojoules per mole. Kilojoules per mole. But before you put your pen down here, you must remember, was the reaction exothermic or endothermic? The reaction was exothermic because temperature was increasing. Therefore, our answer is negative 47. Therefore, it is negative 47.12 kilojoules per mole. The qualitative part of it, you are provided with substance P. Carry out the test below and write your observations and inferences in the spaces provided. Describe appearance of solid P. Solid P was white, so you just write white crystalline solid or substance. Whenever it is white, you just write white crystals. It is acceptable. White crystals. Place about 1/3 of the substance P in a dry test tube and heat it strongly. So you put it and heat it strongly. There is no testing of any gas, just heat it. And then a colorless solution, a colorless liquid actually, a colorless liquid condenses on the cooler part, in the cooler parts of the test tube. That simply tells you that this substance P contains what of crystallization? It is an hydrated salt. That one is acceptable, or you say the salt contains water of crystallization. Contains water of crystallization. So either is acceptable. So if it was a crystal, and then another observation which you can make is that the solid will remain. What will be the color? A white solid remains. A white solid is formed or remains. There you don't need to make any inference. Place the remaining amount of solid D in a pouring tube. Add about 10 centimeters cube of distilled water and shake well. Retain the mixture for test D below. So this one, the solid, dissolve for me a colorless solution. That tells you that the colored ions are absent, and we know the colored ions, which is copper 2 positive, which is blue, ion 2, which is green, and then ion 3, they were absent because it formed a colorless solution, and this is blue, this is green, and this is brown. Therefore these ones were absent. It is also acceptable if you forget this one, you can write soluble salt present. You can say soluble salt present. It is acceptable. Use about 2 centimeters portion of mixture obtained in C for test 1 to Roman 3 below. So add 2 to 3 drops of aqueous barium nitrate. We are adding barium nitrate. We expect a white precipitate because barium will form a white precipitate with the sulfate, the sulfite, and the carbonate. Barium carbonate, barium sulfite are white precipitates. So what is the observation? White PPT formed. So a white PPT is formed. If a white PPT is formed, then it tells you that it is sulfate, the carbonate, the sulfite, okay, the carbonate, then the sulfite is present. Okay, add 5 drops of dilute nitric acid to the mixture above. So the mixture will dent. What will be the observation? We are adding dilute nitric acid 5 and then 5 drops. That is no effervescence. No effervescence. If there is no effervescence, we are adding in a dilute nitric acid, then it means the carbonate, the sulfite is absent, because this one, when you add an acid, they form a effervescence. They produce carbon dioxide, and this one will produce sulfur 4, which will produce effervescence. But this one, so it means that the carbonate and the sulfite are absent. But remember, from our previous, we had the sulfate, the carbonate, and the sulfate. Therefore, it means that the sulfate is present. Because if this one are absent, and in our previous Roman 1, we said the 3 were there. So this one are not there. What is there? This one is present. Acceptable. It is acceptable like that. Add to the mixture aqueous sodium hydroxide droplets until in excess. We are adding sodium hydroxide. The observation is that white PPT is formed. White PPT is formed, which is insoluble in excess. a white precipitate insoluble in excess. So that tells you, we know that what that it means. When adding sodium hydroxide, a white precipitate is formed insoluble. Then we know for sure that the barium, the calcium 2 positive and magnesium 2 positive are there. Yes, we know that the barium 2 positive calcium are present. But now this is our last test. We are going to ignore the barium and the calcium, and then we are going to take the magnesium 2 positive is present. Why do we ignore that? This one forms a white precipitate, which is white, very white. But when you look at this one, they form a white precipitate, but it is not that white. But this one, it forms a very white precipitate, so we just take it as the one that is present. So give the formula of the cation and anion present in the substance. So the cation is magnesium and the anion is the sulfate. The last part of it, number 3, you are provided with an organic substance Q. Carry out the following tests and record your observation and inferences. Place about 1/3 of substance Q on a metallic spatula and ignite it with a Bunsen burner. The observation is that it melts. Solid Q melt and burn with a yellow sooty flame. So if that happens, then you should know it is a double bond or the triple bond that is present. Right? Place the remaining amount of substance Q in a boiling tube. Add distilled water. Heat the mixture and allow it to cool for about 30 seconds. Divide the mixture while still hot into 2 portions. To the first portion, add solid sodium hydrogen carbonate. Then effervescence occurs. It's always observed. Effervescence is observed, then it means that is present. Alkanoic acid is present. To the second portion, add 3 drops of acidified potassium permanganate, and then acidified potassium permanganate, which is purple, then acidified potassium permanganate is decolorized. So if it is decolorized, then inside there could be this a double bond or a triple bond. So you can put even H, but you can put a dash. It's okay. So this one is present. Okay. This is the last printed page. I want to thank you for your time. You are such a good person. Comment. You can have something to say. Just say good work or improve on this. I like what you are doing. I don't like what you are doing. You are free to say anything and then like. Thank you very much.